This is number 40 in chapter 10. I'm going to do part A and part D. Number 40 asks us to determine the molecular geometry and sketch each molecule using bond conventions that we've seen in parts of chapter 10. And so basically we just want to draw these molecules and then also determine the molecular geometry. I'll do both. I'll look at the electronic and the molecular. So for A, part A is looking at BrF5. And so with bromo pentafluoride here, we would need our bromine to expand its octet in order to have 5 bonds. And when we put that structure together, we would still have a lone pair left over on the bromine atom. This would be a Vesper order of 6, and so we should expect an octahedral geometry for the electronic, but then we would actually find that we would have a square pyramidal shape for the molecular geometry. So we're going to write this as a octahedral with 1 fluorine along the north axis and then the 4 other fluorines along or around the equator. Each one of those fluorines with its 6 lone pairs, and then we have our lone pair on the bromine in the southern pole. And so our electronic geometry for this would be an octahedral, and that's what this structure actually looks like. But remember, with our molecular nomenclature, we ignore that lone pair, and so this has a shape that's known as square pyramidal with our molecular geometry. So we're showing again the 3 dimensions with the bonds by showing you the dark wedges that are coming out at you out of the plane of the board, and then we have the dash lines, which the fluorines in back here, that are going away from you to give you that 3-dimensional perspective. That's part A. Part D looks at IF4 with a positive charge on that molecule. And so if we look at our elements, we know that fluorine has to be terminal, so we would expect the iodine to have 4 iodine-fluorine bonds. If it does that, the fluorines all have their octet now, and iodine would actually have 1, 2, 3 electrons left over of its 7 that it began with. But this is IF4 plus 1, and so going to that plus 1, just like with a minus we add electrons, with a plus we would remove electron, and so we remove that 1 unpaired electron, so we still have the lone pair on our iodine. And what we find here is we have 1, 2, 3, 4, 5 groups, and so we would expect a geometry that looks like a trigonal bipyramidal structure. And so here we have that electronic geometry of trigonal bipyramidal. Since it is since it has rather 5 different groups surrounding that iodine. But when we look at the molecular nomenclature, because of that lone pair, this actually has the shape known as a seesaw. And while it might be hard to see that with the structure as I've drawn it on the left, if we rotate it a little bit, we then see that shape of a seesaw here. So we see 5 groups. We are trigonal bipyramidal with our electronic geometry. That gives rise to a molecular geometry known as a seesaw. Again, we're using that positive here to remove an electron, which is the opposite than if we had a negative there. That is number 40.